Now, chords and segments. Now, I'll start by trying to draw a diagram. A segment is formed or is an area covered by a chord and an arc. So this arc, either in terms of the arc being minor or this arc being what? Major. So this is a segment. We call this a major segment, and this is also a segment. We call this a minor segment. So it is the area covered that is a segment. So this is a minor segment, and this is a major segment. I don't know how segment was introduced to you before now, but I'm taking a different approach. So you really need to pay very close attention to what I would say. Now this is one diagram. So the big question now is, how do we find the length of a chord? Because that's the first thing you need to take note of. How do we find the length of a chord? A chord is essentially known in mathematics as a decreasing, or chords are decreasing diameter. Chords are what? Decreasing diameter. So there's a formula for it. So the length of a chord is equal to d sine theta over 2, or 2 pi, or 2r sine theta over 2. Now let me explain that. Let me explain this carefully. So I'm going to state out the parameters here. D is equal to diameter, r is equal to radius, theta is equal to the angle subtended at the center. And when you are solving problems, there's also another approach we use where we draw triangles or whatever, but sometimes you are very sensitive. You will be able to get the diameter. Once you are given the radius and you know the angle subtended at the center, please use this formula straight away and don't waste our time. I noticed something with modern wire questions. It's more, questions today are more Cambridge-like. So gone are the days where we spend quality time solving problems. No, today is not the case. We need to adjust ourselves to, so your ability to practice and always remember your formula or your key ideas, it become very, very essential. All right, so that's that for that. So let's take a practice question. Find the length of a chord given that radius equal 7 cm and angle subtended at center is 60 degrees. So what's the length of this chord whose radius is 7 cm and the angle subtended at the center is what? 60 degrees. All right, the length of chord is 2r sine theta over 2 equal to 2 times 7 sine 60 over 2. So what does that mean? That will mean that this will be what? 2 times 7 times 1 over 2. And that will be 7 cm. So spot on for that person who did that. Spot on. Right. Okay, let's have some practice questions. Area of segment is quite, that one I'll have to use a full class for that. It's quite interesting. So perimeter of a segment. Now, the perimeter of a segment is actually the length of arc now plus the length of chord. So if the arc, if they say find the major segment, it will be the major major arc plus the length of the chord. If they say find the minor segment, it will be the minor arc plus the length of chord. All right, so let's take a typical example of how to do this. So classwork. Given that the radius of a circle is 15 cm, let's use 14 so that we can cancel out easily, and the angle subtended at the center is 210 degrees. Find the following. Let's copy the question down. Plenty questions I'm going to give you now. Find the following. Given that the radius of a circle is this and the angle subtended at the center is this, find the following. Number one, length of minor arc. 2, length of major arc. 3, perimeter of major sector. 4, perimeter of minor sector. I can just imagine the kind of the questions that will be going on in some people's minds now. 5, area of the minor sector. 6, area of the major sector. 7, length of a chord formed. 8, perimeter of the major segment. 9, perimeter of the minor segment. So what do you see here? You see that with just this little information I gave you here, you can have 9 different iterations or even more questions that can come out of that. So I'll read the question again. It said, given that the radius of a circle is 14 cm and the angle subtended at the center is 210, find the following. 1, the length of minor arc. 2, the length of major arc. 3, the perimeter of major sector. 4, perimeter of minor sector. 5, the area of the minor sector. 6, the area of the major sector. 7, the length of a chord formed. 8, the perimeter of the major segment. 9, the perimeter of the minor segment. Let me even add another one. 10, the diameter of the circle. 10 questions from this. Now, I'll just give you a little tip because I will expect you to do this and submit in Google Classroom. I'll give you a little tip of what you're expected to do. The angle given to you is 210. So what kind of arc, sector, or segment will it form? It will be major. So this 210 will be major. How do you get the minor? The minor will now be what? 360 minus 210. Generally, the minor arc, sector, segment are formed by angles that are less than 180. Once the angle goes above 180, what you're going to have will be what? Major. So please let's take note of that. It will be what? Major.